All right, so this is just a quick update. I just really kind of want to, I think, show. I got to get going on a bunch of things, but a really quick update just to show the kinds of surveying that I propose was done just relative to the fact that I'm seeing things here at Machu Picchu as done on other videos. Here in Vermont at the Meadowhouse Observatory, what I posit was once a larger continent of mu or landmass. Some may think maybe that's the sort of Atlantis idea, you know. I don't know where to go with it except for the fact that I think I'm just looking at the calculations of southern hemisphere glacier loss and the amount of ice and water that would have had to have gone somewhere. And, you know, look at the continental shelves of all of these land masses and things that we know about, you know, all of the built soils and engineered by humans of ancient civilizations and all of these sites that I've mapped out across everything. You know, these are all my data points. So basically what I've done is run triangles of equilateral proportion of 3,965 miles. That's those blue lines. They're pretty much the exact same. In some cases, like one or two, there's a 3,966, and in one or two it might be 3,964. But in whole, if you see these blue lines here, those are all the exact same dimension, and they form kind of like a pyramid grid. I want to say a tetrahedron, as if you think of it as pulling to the inner core on a point unseen from these white stars into the, you know, center of the earth, if you will. So that forms those planes around, you know, basically you get 1, 2, 3, 4, 5 perfect pyramids or triangles, equilateral triangles, and one piece that is the difference. So in this case, anywhere there's a green line, that measures 728 miles. Here I've used it at the south end of Africa from a particular location of the West Coast Fossil Park, and various points of intersection relative to this equilateral triangle, other points where from South America we have our same exact blue line that forms an equilateral triangle back through the intersecting essentially circles of equilateral triangles coming off of Meadowhouse as well. So they intersect, and that is this point. It's pretty slick in my sacred geometry kind of mind. I just find it absolutely stunning, and it's not perfect in the sense that these peach lines are equal to these peach lines. I think it's like 1200 versus 1160 versus 1240, 1220 and 1110. I don't know. Let me go check. It's one of those things where I know that idea of measuring stretch as it relates to, yeah, 1121. So 1121, and then this one here is, you know, if we're measuring that one's 1242 miles. So those are isosceles triangles nonetheless, because those green ones are also equally 728 miles. These purple ones form I think it's like 100 and, let me just pull it up exactly. That's an equilateral triangle, and that forms 623 miles from these points of intersecting relevance to what I propose was some kind of deeper form of surveying the Earth previously. And in it, there's complexities up in here I got to work through as far as how all of these pieces relate. But again, here too, we've done this before. We know these are 728, and that number is, let's grab that right there. That one is 1232. So that's kind of in a peach in that range. Statistically, it's all kind of there, in my humble opinion. This is a different equilateral triangle that, you know, as I'm trying to understand how things would be measured from various points along radians, you know, that's kind of a level of deeper looking at the bigger theory. But Again, let me get rid of that issue. Gotta go update the password. So this is basically, again, anywhere there's a blue, that is the 3965, 3964 miles, kind of in that ballpark. And so I got to clean up a little bit, maybe potentially reorient some other intersecting lines to see if that's a thing as it relates to surveying and understanding all these land masses all around. Again, anywhere there's a green, that's the 728 miles. So yeah, it kind of works itself out. And there's a way that then you would imagine, or I would imagine, you could calculate all of the things that you need to calculate to figure out all of the things you need to figure out from kind of a big perspective of, how did we ever figure out the tilt of the Earth to begin with? How do we figure out the rates at which we spin and the speeds at which we're going relative to northern hemisphere, southern hemisphere, the stars in the sky, all of it. There's a lot that goes back before the stuff when you think about, well, who came up with stuff, and sure, okay, but maybe there was other stuff before that was happening that was actually really, really cool. And when they're not it's not that they're not given credit for it because they didn't do all the right things. It's just time and happens of catastrophic proportions. And, this is what I've come up with. So I'm going to keep trying to advance this a little bit further to try to clean it up and see if I could figure out if there's a ratio of how to calculate these things, but that'd be pretty OG to know exactly how those original roots of knowledge were kind of coming into formation for us human kin. All right, peace all.